let's start talking about circles. And let's start by talking about what a circle is. A circle is the set of all points in a plane that are equidistant from a given point called the center of a circle. All right, let's break down that definition a little bit more here. First off, the set of all points. A set is basically a collection of things. So it is saying every single point in a plane, so that means we're talking about a two-dimensional surface, a two-dimensional space here. In a plane, so we're collecting every point on this two-dimensional surface that is equidistant from a given point called the center. All right, so what that means is that there are two pieces that we need to determine a circle. First, we need to pick a point to be the center of our circle. And secondly, we need to pick a distance, and that distance is going to be called the radius. So we have a point that's called the center. So center will be about here. And then we pick a distance, let's say 5 inches. And the idea of a circle is that every single point on the circle will be the same distance away from my center. And it's every single point, it covers every single point that is that distance away from my center. In other words, what I'm doing is I am collecting every single point that is 5 inches away from this point. This point is called my center of the circle, and that distance of 5 inches is called the radius of the circle. So we are picking a point to be my center and a distance to be my radius, and that's what makes up a circle. So the radius is a distance from the center of the circle to any other point on the circle. And one thing you're going to need to keep an eye out for, especially when we start to talk about segment lengths, is you should keep an eye out for any radius. Because as soon as you have a radius, if it's a segment that goes from the center out to a point, then you know how long that segment is, because it's a radius, and so it's going to be the same distance every time. If I go from the center and take a segment out to this point, it's going to be 5 inches. If I take it from the center and go out to this point, still 5 inches. Center out to this point, guess what? 5 inches. As long as we're going from the center out to a point on the circle, it's going to be that same distance. If we're going twice as far, in other words, if we're going all the way across the circle, then that's going twice as far, and we would double that distance to 10 inches. In other words, it's basically taking a radius and laying it end to end with another radius to go all the way across the circle. And that distance is called a diameter. So in other words, it passes through the center of the circle. It goes all the way opposite ends of the circle, from one end of the circle out to the other. So it is a segment that goes all the way across the circle, crosses through the center, and is twice the length of the radius. So if you got the radius, you've also got the diameter. So for a circle, we need two things. We need a center and we need a radius. Diameter goes all the way across. That's our recap of what we've done so far. I'm going to recap these every little bit of time so that we don't get overwhelmed here. All right, so if the segment goes through the center, we call it a diameter. If the segment goes anywhere else on the circle, we call it a chord. So a chord is just a segment whose endpoints are on the circle. So if I'm going, in general, from one point on the circle to another point on the circle, that is called a chord. Remember that if it goes from one point on the circle to the center, that's called a radius. If it goes from one point on the circle to another point and it goes through the center, it's called a diameter. But if we just started a point on the circle and ended another point on the circle, that's called a chord. If we take that chord, that segment that starts and ends at a point on the circle, so we got 2 points on the circle, we connect them. If we extend that out to a line, then that is called a secant line. So a secant line is a line that intersects our circle at 2 points. If we have a line that intersects the circle at 1 point, at a single point, that is going to be called a tangent line. So the idea of a tangent line is that it crosses through the circle and just grazes by it at that one single point. That's better. So it's going by and it just grazes by at this one point on the circle. So unlike a secant line, it's not going to come inside the circle, it's just going to be right on the circle. And that line is called a tangent line. And actually, a tangent line of a circle is related to why that trig ratio was called tangent. But that's a pre-calc idea, so I just want to mention it here, but I won't show the whole idea of why. Okay, let me go a little bit farther, and then we'll, when we get to the end of this page, we'll recap again. A central angle. Okay, this one's pretty easy. A central angle is an angle at the center. All right. So in other words, the vertex, right, the point where the angle meets and makes the angle itself, is at the center of the circle. So in other words, we have two segments. We have a radius coming out of here. We have a radius coming out of here. And that makes a central angle, angle at the center. And when we make those kind of angles, we trace out kind of distances along the circle. And those distances along the circle are called arcs. So if I take from A and trace out on the circle along to B, that is called, what I've just traced out is called an arc. So in other words, we can figure out measures of those arcs. For example, if I just measure the arc that goes out all the way around the circle, then it's 360 degrees, because 360 degrees is all the way around the circle. If I have a semicircle, which is what it's called when I go halfway around the circle, well, if all the way around is 360 degrees, then halfway around the circle should be 180 degrees. That would be the measure of an arc that is just going halfway around the circle. In two more terms here. If we are going less than halfway around the circle, we have a smaller arc. That means it's going to measure less than 180 degrees. Then that's going to be called a minor arc. If we're going more than halfway around the circle, and that means the circle is going to measure more than 180 degrees, then that's going to be called a major arc. And it's going to measure more than 180 degrees. It's going to be a bigger arc because we're going more than halfway around the circle. So one thing to know is that most of the time what you're going to see, how we're going to label these arcs. Because if I say we're just going to trace out the arc that goes from A to B, there's actually two different ways to trace out a path from A to B. We can take the short path, like I had done before, and just trace out, there's my path from A, start A, go there to B, done. That's pathway number 1. Pathway number 2 is we could take the long way around. And we could start at A and trace our path out the long way all the way around to B. That would be the major arc. And so when we label these, if we are just having a minor arc and we are taking the shortest path from A to B, we are just going to call it AB. If we have a major arc and we're tracing it out the long way, then we're going to specify that by using 3 letters. We're going to say, no, I want, right, if I just say AB, then you're just going to take the shortest path. So if you want me to take the long way around, we're going to pick another point, C. We're going to pick another point and say, I need you to, before you get from A to B, you got to go through C first. So that tells me to trace out the long way around, start at A, trace out to C, through C before I get to B. So short version of that is that a major arc, if we have the long way around, we're going to use 3 letters to name it. So that I know to start at A and then I have to go through C before I get out to B. So remember, measure of a major arc is going to be more than 180 degrees. Measure of a minor arc is going to be less than 180 degrees. 3 letters to name major arcs. Okay. Before I go on to the next page, we've actually got most of these down already. So before I go on to the next page, let's do a recap here. I'm going to go a little bit quicker. Circle. You need 2 pieces in a circle. You need the center. You need to pick a point. We're going to call it the center. You need to pick a distance. We're going to call it the radius. And the circle, that all the points on the circle are going to be that same distance, that radius away from the center of the circle. So if we have that segment that goes from the center onto any point on the circle, that's going to be a radius, and it's going to be that same distance every time. If we go from one end of the circle to the other and cross through the center, that's called a diameter. If we go from any point on the circle to any other point on the circle, then it's just called a chord. So chord, pick 2 points on the circle and connect them, that's called a chord. If we extend that out to a line, it's called a secant. If the line just passes through one point on the circle and grazes by and doesn't come inside the circle, then that's called a tangent line. Central angle is an angle in the center. Halfway around a circle would be called a semicircle. And we have 2 different types of arcs. We have a major arc, which is more than halfway around, measures more than 180 degrees. And we have a minor arc, which is less than halfway around, measures less than 180 degrees. Major arc, we're going to use 3 letters to say that we want to go the long way around. It's kind of like the difference between an acute angle and an obtuse angle. We have a cutoff and we're measuring bigger or smaller than that. All right, questions so far? All right, let me go on from here. Here's some easy terms. Congruent circles and congruent arcs. Guess what? Congruent is going to mean the same thing it's meant the entire year, which is that things have the same measurement. 2 things that have the same measurement are congruent. And so if I talk about congruent circles, well, the only measurement we have in a circle is its radius. Right? We have 2 parts. The center, which doesn't really have a measurement, it's just a point. And then the radius, which does have a measurement. So as long as 2 circles have the same radius, then they're congruent. If 2 arcs measure the same, then they're congruent arcs. By the way, if we're talking about more than 1 radius, like we are here, the plural of radius is like the plural of cactus. So it's going to be radii is the plural of radius. So if I have more than one radius, then I have multiple radii. All right. So we've already talked about a central angle, which again is an angle that's at the center. Now, if the angle, instead of being at the center, is on the circle, then we call it an inscribed angle. In other words, the vertex, which is the place where the angle is going to meet, is on our circle. There's our vertex. And here is the angle. So that angle, this angle right here, is called an inscribed angle. So here it is again. It's on the circle. And it can form an arc. Like here. And that arc is called an intercepted arc. So an intercepted arc comes from an inscribed angle. All right, 2 more to talk about here. We're almost done. If a whole shape is inside a circle, we call that, whatever shape we're talking about, we call it being inscribed in the circle. So just like if an angle is on the circle, we call it an inscribed angle. If an entire shape has all its vertices, all its points on the circle, then we call that shape being inscribed in the circle. And we say that the circle is circumscribing the shape. So mostly you'll just need to know, you won't need to come up with that term. You'll mostly need to know if I say that a triangle is inscribed in a circle, you should be able to draw what that looks like. It's going to be a circle, and then there's going to be a triangle happening inside of it. So the idea there is the entire shape is inside of the circle. And then to wrap us up, sometimes we'll have these segments, like these chords and these secants and these tangents. Sometimes we'll want to talk about pieces, especially if we have multiple segments going on at once. Then sometimes that's going to, for example, split this chord into pieces. So those pieces are called like segments of the chord. This is a secant segment, because a secant is actually a line. So if we just want a piece of it, then we call it a secant segment. This is an external segment, so sometimes you'll hear me talk about what is outside or inside the circle, or what's in the exterior or interior of the circle. And then, by the way, we'll end this chapter by talking about how to put circles on a graph. And so this will be the way that we're going to put circles on a graph when we get there. So that's basically all the terms that you're going to need to know for the next month. For this next chapter here. So let's go through it all one more time here. Recap all these ideas. And then what I'm going to have you do is I'm going to have you label parts of the circle. I'm going to give you a diagram with some circles and some lines and some segments and ask you to give me examples of these terms. Okay, so let's recap it one more time before I do that. Circle needs 2 things. It needs a point that I choose, called the center. It needs a distance, called the radius. And all the points on the circle are that same distance away from the center. I'm going quicker this time. So a point called the center and a distance called the radius. If we go all the way across from one end of the circle to the other, that's a diameter, crosses through the center. If it doesn't cross through the center and I'm just picking 2 points on the circle and connecting them, that's a chord. If I extend that chord out into a line, it's called a secant. If it just, so a secant line is going to go inside the circle. It's going to cross through inside the circle. If it doesn't cross through the circle and just grazes by and ekes by on one point on the circle, that's called a tangent line. Central angle, it's an angle in the center. We have two types of arcs. We have the minor arc, it's the shortest path, and it's less than 180 degrees. And then we have the major arc. We're going to use 3 letters to name it because we need to go the long way around. It's going to measure more than 180 degrees. Central angle, it was at the center. Inscribed angles are on the circle. And the inscribed angle makes an arc called the intercepted arc. If 2 circles have the same radius, they're congruent. If 2 arcs have the same measurement, they're congruent. A polygon that's inscribed has all its vertices on the circle. So the shape is entirely inside the circle, and we call the circle being circumscribing that polygon. And sometimes we can have our chords and our secants and stuff broken into pieces and segments. And then we can also put circles on a graph, and that's how to do it. So those are all the ideas and vocab and terms that we have. And we're going to do some stuff this week to help us practice being familiar with those terms. The first of those that I want to do, and here's where we get to the top of our notes here. These notes, by the way, are going to be due middle of next week. That's when we'll be finished with these notes. What I want you to do, I want you to take about 5 minutes. And I have some terms here on this first page. And I don't want you to fill out the definitions because we just talked through all those definitions. Okay, that's not what I'm worried about. What I'm worried about here is the column that says example. And so I want you to take that diagram that's off to the right, and I want you to find me examples of each of these terms. So I want you to give me an example. The first one is circle. So give me an example of a circle. Think about how would we, how might we label a circle? Give me an example of a center. Give me an example of a radius. Give me an example of a diameter. And so on. When I go through it, I'm going to give an answer. There are multiple correct answers. For example, if I'm talking about center, since there are 2 circles there are 2 centers of the circle. Oh, thank you.
Put your name in them and stuff.
Okay. There are 2 centers. We have this circle, its center is at A. This circle here, its center is at F. So there are 2 different answers you can put. I'll just put one example of each, but other answers may be correct as well. But I want to give you about 5 minutes here. I would go up to secant. Here we go. I'm going to go through these pretty quickly here. I'm just going to give one example. So yours may also be correct that you came up with. Circle, just like with a triangle, we're drawing a little triangle and then labeling the points. We're going to do the same thing for a circle. We're going to draw a little circle. There's our little circle. And then we're going to label a point on the circle, which the point is our center. So this circle over here is circle A. And that's how we would label it. So we're drawing a little circle and then labeling the center. Radius. One example of a radius would be segment FN. It goes from a center to a point on the circle. Diameter. I to j is the diameter. Goes through the center. An arc, let's see. N to E is an arc. Right? That would be this arc right here. It would be a minor arc. When we want, so we're drawing a little arc symbol, kind of like how we draw little segments or angle symbols or something like that. If we wanted the measure of arc NE, then we would put a little m before it, just like we do for angles. Notice I put segments above radius and diameter. Chord. Chord is also a segment. K to L is a chord. A tangent line is going to just touch at one point on the circle. So C to B is a tangent line. A secant line, G to H is a secant line because it goes through 2 points. And that's, notice I put lines here because these are lines and these are segments. All right, one more thing to write down before you go. On the next page, there should be a box on, there should be a box on the top left on the second page. It says central angles. The angles are formed by 2 radii. There's plural of radius. And the vertex is located at the center. It's an angle at the center. And we're going to have formulas for how we can find the measure of the arcs of these different types of angles. For a central angle, it's easy. Measure the angle and the measure of the arc, they're the same. So this is 70, this is 70. And then we'll talk about the rest of them and how the rest of those boxes are filled out tomorrow.